Good afternoon, sir. Hello. Good afternoon, sir. Hello. Yes, sir, you can start the session.
Hello.
Good afternoon, sir. Am I audible?
Hello.
Yes, sir. Am I audible?
Hello.
Hello.
हॅलो.
Yes.
नाही येत नव्हता. हा 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 ओके ओके. हा हा बरं. हा हा ठीक आहे. सुरू करू. हा ठीक आहे. ओके ओके. एक मिनिट. ओके. हॅलो. 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 हा हॅलो. हा एम आय ऑडिबल मॅडम? हॅलो. 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 हा मॅडम माझा ऑडिओ येतोय का? नाही आता हा फोन मधला नाही. आता बघा याच्यामधून म्हणतोय प्रेझेंटेशन मधून. हॅलो. हॅलो. प्रेझेंटेशन मधून येतोय का म्हटलं? हा ठीक आहे. ओके स्टार्ट. So yesterday we discussed about Honeywell a little bit architecture and what are the main hardware components in Experion architecture. Today we'll see furthermore how it is implemented in the plant. So we are talking about RCF example, ammonia condenser stripper automation, where condenser is there, and from there energy saving is more here. You can see here earlier it was a low pressure, now it is after medium pressure. And when a medium pressure was this equipment was process equipment was installed, that time Honeywell latest DCS was uh, implemented for this automation. So we got almost 0.2 million kilocalories of energy saving. These slides were discussed yesterday, so I'm going furthermore. Uh, But here I am showing the one loop to understand more clarity. So medium pressure steam flow, this is the steam line. There you can see here orifice plate for measuring the flow, steam flow. And this is the orifice plate here, this one. And in the PNID, you can see here, which is circled here. So, and this is your FIC. And this is your transmitter here to measure the flow. And actual transmitter is picture is shown here. And this is the controller, Honeywell controller, series C is in the control room, where in that control room, this FIC 1301 controller tag or module is executed. So this loop is this much. You try. This is simplified to understand it. So this is the medium pressure steam flow loop PNID. Okay, and very important part or a critical part we can say, uh, there is a fuzzy logic and redundant solenoid walls. You can see solenoid walls also redundant here. I will show you. So this is a wiring diagram. We have discussed the, I have shown yesterday this junction box, close, open. This is a trip logic for medium pressure steam header flow. See how critical it is. You see here, manual trip. Even you can have a manual trip which is in the auxiliary console. Yesterday or day before yesterday I have shown one panel. There the operating senior operators or senior operating staff is operating when the system is not responding, or due to maybe the sensor fault or maybe any other fault in the software. So they manually trip. This is a one trip. Reformer flow rate, if the reformer flow rate is not proper, then also this will trip. Or condensate level is high, then also trip. So there are three parameters here, which are responsible for tripping the medium pressure steam header flow. Means to stop the steam, these are the three important criteria. And once this logic is executed in your DCS or PLC, then you can see here, this is the logic solver here. This is a symbol. And then finally it goes to the solenoid valve to operate it. Means solenoid valve is either on or off. So here our condition is to stop it. So close the valve. So this logic is here. I mean going back is here. You can see here this solenoid valve will force this control off if any of the three conditions are not satisfied. So that is this loop here. So this is the overwriting on the normal FIC loop. So this is the transmitter I have shown. This is the control wall, and solenoid walls and all back accessories you can see is, back side, rear side of this picture. I will show you some another picture. Rear side, this side you can see solenoid wall assemblies are there to force this control off position or close position. This is a hard positioner from Siemens for the control wall, and you can see the opening of the wall shown here. And here it is showing 39 because the picture was taken earlier, and this is the what. But actual readings are happening here. Real time picture values are coming. If you are not, suppose you have taken a picture of screenshot of the uh, pneumatic sorry hard positioner, and then later on maybe a half an hour you went to the control room and taken screenshot, so the difference will come. But for understanding, take it that both are real times. So the solenoid assembly I was searching in the logic, you can see these are the solenoid all here. Yes, this is a fuzzy 31301 loop, and you see solenoid walls are redundant here. Here you can see the solenoid walls. This one black portion one, and this is another solenoid wall, redundant. So these solenoid walls will force the steam flow to stop, close. Then medium pressure steam flow loop control wall installations, which you have already seen here. This control wall is here, and I have shown you this is the hard positioner. Normally we see pneumatic positioner. If it's a mechanical type, this is a hard positioner. Mm. So if you see the rear side of the linking of the hard positioner with this stem of the control wall, this you can see this is a stem, and here this linkage is there. Here it is linked to this back side, and solenoid assembly is this side, you can see, which is forcing this wall to stop. So this I have shown already. This is what input junction box. In the junction box is in the field. This is a new junction box, therefore it is very looking very view. You can say very clean, and actually it's a in the project time we have taken a picture, but normally it becomes a dirty after use because it is in the field. So you can see individual pair of cables from field. This one, this one, this from various transmitters. Hmm? So these pairs are coming here, and outputs, individual outputs. Also, you can see an individual pair of cable from the field instruments like this, output, input, whatever. It is difficult to identify it, but normally uh, uh, one side input, another side output, like this it is done. And this is the multi-pair cable, so it goes to the control room. So this is the what multi-pair cable goes to the control room. So you understood now, from the junction box to control room, the signals are carried on the multi-pair cable to control room, right? So I was talking about a trip logic in medium pressure steam header flow. So manual trip, reformer flow, and condenser level, and this is the OR logic, and your solenoid gets operated and wall gets stopped. And this is a redundant solenoid wall. If you can see, if this solenoid is maybe because of electrical or maybe mechanical fault, if it's not operated, this solenoid will take care of operation. Now I'm coming to the PID closed loop implementation in Honeywell Experion in the medium pressure steam flow. Hmm. So field area, this is a basic concept. Transmitter JB in the Honeywell FTA, AI card, C300 controller, IO link. This link is missing here. Again, you can see this redundant link. So IO link here. So this part is miss, but you can see like this. And output goes to I2P control wall. Then control firewall, FT and server. So this is the what Honeywell last yesterday or today we are discussing. This is what you have to remember, and that will increase your aptitude in the interviews, in the professional interviews. Definitely it will help you, this diagram, this picture, you understand this. So this IO link is here. Actually you can see now Honeywell are products in the line, in the loop, or in the field. So field area, uh, I have shown you this transmitter ORP split. Then transmitter also I have shown, right? You can see here also by clicking, but I'm not going back now. This is a flow transmitter, and from flow transmitter it goes coming to the junction box, single pair, which I have explained you. And from there multi-pair cable carries the signal to the control room. So this is a control room part where you can see here, this is a marshalling cabinet, and from marshalling cabinet, this is ammonia plant hazardous, so you can see intrinsic barriers, IS barriers this side. This is a terminal strip with a fuse link, IS barriers, and from there signal goes to the analog input card here, and which is a dual redundant. This is a dual redundant card. This is AI card, Series C cards in the Honeywell system. From there, signal goes to controller. So this is the Series 3 controller, C300 controller, which is a dual redundant. And here your this PID loop algorithm is executed, and from here output is generated, goes to the output card. So you can see here output cards redundant, and this analog output goes to the marshalling cabin. From there again on this cable signal coming to the field junction box, and there it goes to I2P and control wall. So overall this is the way hardware is installed, and it is a scale down. Suppose you have 100 loops, so you can see here your devices will be 100 here, maybe cards into 8 AI, 8 AO. So accordingly your cards will increase. Controllers for 100 maybe 2 or 3, like this. The your hardware, you according to the size of the system, you have to select or procure and install. Then from the controller, the signal goes for display through FTE, but here there is a firewall redundant for protection. And there from this FTE means fault tolerant Ethernet control network in the Honeywell, and this is your workstation graphics. So for this particular section MP uh, condenser stripper, here you can see this graphic. You can see this condensate levels, and this red line is your medium pressure steam flow rate. So as I have explained the how critical logic it is. Hello, hello, hello. स्लाइड दिसत नाहीये. एक मिनिट, आता ही दिसते का? कोणतीच नाही दिसत. ओके, परत मी रिस्टार्ट करतो जरा प्लीज. हा, ओके ओके. Hello, hello.
It is visible, visible.
So I'm going to the last the slide which we were discussing. These slides we have yesterday discussed. So I'm skipping fast. So I'm here. I'm explaining loop, critical loop in the system, and that you have to remember all the times. This I was this is visible. Hello, 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 just hello, hello, hello.
Yes, sir.
Visible slides? Hello?
Yes, sir.
Slide is visible, na, madam?
Oh, yes, yes, yes.
ठीक है. So we were discussing about hardware, and uh, I have explained this Honeywell Experion system. Now we are going ahead with the controller features. See here, this is a Honeywell controller. This is the picture of, and you can see here very clear the this is the plane where it is installed, and other connectors are for IO link, FTE, redundancy cables. If redundancy for controller is there, from here the cable goes to the like this another back planes, and RAM battery, device index switches. So this is the way a new series C they have a system. So same thing, it is mentioned install in a control cabinet on vertically mounted carriers specifically for series C control hardware. So there are so many benefits of this, and you can see here this controller has continuous control blocks, functional blocks, algorithms, logic blocks, sequential blocks, and model based control blocks. So these are the very important software algorithms are inside the controller, and therefore the controller is a very uh, we can say critical device in the systems, as well as it is the heart of the system, and is a cost wise also very high. Controller functions are continuous logic, sequential, and model based. Sorry, each function block contains a rich set of predefined features such as alarm setting, different algorithm choices, maintenance statistics, which are enabled by configuring parameters, which when we see the actual screen of the configuration, there you can see alarm settings, choice, various choices, and maintenance statistics. So function blocks are combined and interconnected through soft wiring. We'll see that soft wiring means you can see the control modules, input block, output block, and then we have a wire link like this soft wiring in either control module or sequential control module to perform a specific control task. So based on your control tasks, you have to select the blocks and do the wiring, enabling efficient strategy engineering. So you will get a actually strategy. So this is what my control strategy, and when you download it and execute it, you will find the in the simulation mode, you can check also. So embedded functionality guarantees the consistent control strategy execution and delivers a consistent alarming and operational behavior. So these are the features of the controller. This consistency reduces operator errors and saves implementation time by eliminating the need to create low level basic functions. So there are so many advanced features, user friendly features are there in the new series of the controller. Second important device is a control firewall. So control firewall, this is the hardware where you can see again, this is the install on this plane, where you can see the power LEDs, status LEDs, and you can see here uplink FD port, FT port LED, downlink FT port means downlink means how many controllers are there, nodes are there. These are the they indicates here ports 1 to 8. So provides communications from C300 controller to the supervisory network means see in between supervisory network means workstations and or servers. This device is protecting. allows the control data access signal from supervisory side to controller sides. See here. Then provides the network security by rejecting all Ethernet messages not needed for control. This is very important part here. Giving priority to traffic on downlink ports or ingress traffic on the uplink. So normally downlink ports, he is giving a priority to collect the signals which can server can access it. If, for example, like the alarm is there, so from the system side alarm is prioritized for the supervisor network. If the fabric becomes saturated and allowing only valid C300 control compliant messages to pass on to the C300 domain. So this is the what uh, control firewall has a functions. Now I am coming to series C IOs. So you can see here, this is a hard analog input card, series C module. IO termination, because here IO termination is required. As I told, IO termination has the electronics for signal splitting and signal isolation, optically isolation. So this termination is here. You can see the connectors here for duplications. And you can see in the cabinet, IO cabinet or system cabinet, you can see the series CIOs and C300 controller. So you can see here in this cabinet, in a single cabinet, you can see one by one now. These are power supplies, bulk power supplies, and this power supply is also redundant. And you can see on the top these two power supplies. These two are you can see here firewalls. These are firewalls, and these two are four. You can see here now, these are primary controller, secondary controller. Primary, this is a second controller, this is another controller. So these are the controllers, two controllers you can see in this pictures, which are both are redundant. Then IOs, you can see at this side IOs. So in one cabinet you can see almost your all IOs and power supply, everything is resetting. That means 5 to 20% space reduction over a competitor. Suppose you require 10 cabinets, so at least you can save, you can have 6 to 7 cabinets is sufficient for that. So that way your space is reduced. Easy installation and maintenance, that way it's easy, because no congestions, no loose connection for other areas. It is a separate, this board is separate, this board is separate. So improve thermal, as I told yesterday, there is a space, sufficient space between each card, so improve thermal management for greater IO reliability. So life of the cards is increasing. This picture has taken other to, you should know the height of the, means you have seen front, now you can see this side, one side, you can, this is the size of the card, and you see these connectors and all like this. So I have shown same card but in the different angle, so you can understand the size of the card, right? So this is analog input, this is what marshalling cabinet, and then it is coming to the this rack. So this is a marshalling, nearby this is the cards, this is the card, big picture. Hello, hello, hello. So you can see here, I have shown analog input cards, analog output cards. Now discrete input cards are here. Digital inputs and digital output cards. You can see by identifying here number of cables, because these are 16 channels, 32 channels. Like these cards are, card has a density. So this is a discrete inputs, discrete outputs. Then redundant IO link. You can see here IO link is also redundant. Honeywell series C, you can have IO link for IO communications. So you can see here IO link cable here. These the two cables, redundant cables. This IO link. Sorry, these are the cables for IO link. I'm coming back. So you can see here, one side cable. This is the slightly different cables colors. So these are the IO link cables. You can see here this side. So on control firewall, this is a control firewall. This is a FTE network. Then all signal coming primary network switch second. These are standard network, Cisco network, Cisco or any reputed. And this is the server, normal piece, server grade machine, Dell. So I'm showing how the system is installed. This is the system cabinet in RCF, and when you open it, you can see these cards here, IO cards. This IO cabinet. So this is the what inside the cabinet you can see the cards. This side your intrinsic safe barrier, then connectors and these cards. This side you can see the, as I told, uh, IO link and FTA boards are there. And this is the control room where you can see workstations and all operating staff. And this is auxiliary console, as I told. When the system any tripping is done through this, operators are senior operators using this panel. And these are DCS workstations. 1, 2, 3. However, this is the auxiliary panel for various sections. Hello. As I told, control room space is very important. You can see here congestion of the cabinets and space. This is the these are the cabinets. These are the cabinets, and you see these cabinets are rear side. Means you can see uh, behind this screen. These cabinets are there. These. So the space are challenges here, and this much space is when you open this, you cannot pass through this. That much. Uh, Space constraint is there. So whenever you have to do work, you can open only one cabinet like this. So in this space you have various cabinets, marshalling cabinets, IO system cabinet, IO cabinets like this. Hmm. So marshalling cabinet termination, just you understand here, termination in between there is a fuse link, very easy termination. There is no much uh, in the house when you have to replace our switch, this is a lot of difficulties come, but here it is a push and fit. You suppose you have to isolate this, just push it and it will come out and signal will be isolated. So like this, and these are the intrinsic safe barriers, as this is ammonia plant. Mm. As I told, very congested for a demonstration, you can see how difficult to demonstrate backspace. Therefore, I have taken a pictures and shown you. So one of the batch we were demonstrating, but it was very difficult for 5 to 6 students only stand there, or any professionals also from different companies. They attend the program, so it is difficult at a plant side. I'm not talking about a Honeywell side, but Honeywell side training, you cannot see this type of a huge installations. You can see controller, you can see, as I told, how to generate once you understood the controller IOs, and then you are more or working on the features, how to create a control module, graphic, linking, alarm, everything. So that part you can learn on their center, either in person or online also. So this is the one cabinet where you can see, as this is a very old plan. So earlier we have PMIOs. So these IOs are also connected to the controllers. These are the controllers. Power. There are two controllers you can see. Both are redundant. Mm. System cabinet two. You can see firewall and controller here. You can see this is one controller. The redundant controller. IS barriers means intrinsic safe barriers installed here. You see here by barriers. And this is the control room, as I already shown you. The in control room, you just take a look. This one is a auxiliary console, and remaining is your DCS workstations or server stations. They call it the server stations. The This operating staff is sitting here, right? So these are you can see alarm and shutter. then push buttons for manual tripping or manual switching on and off like this. Mm. So in the condenser stripper, this is the graphic screen and this is actual picture in the plant. This is the condenser stripper and this is the actually graphically. So values are real time here. Mm. So this is the medium pressure steam flow condensate level. I will show you. And you just see the screen here. Alarm screen, alarms, system menus are there. So Honeywell Series C IOs, redundant IO link and card status. There is a one for engineering station. You can see system view. When we say system status view, actually you can see the status of the cards, healthy, redundant, under maintenance due to different colors. You can see blue, sometimes this color. So that indicates the health of the systems and size of the system inside the card. So actually from in the system you, whatever you are configured or under a process of configuration, everything will be shown here on the screen. So you can see here the controller, two controls are shown and their status are shown here. So if there are controller is the primary here, then primary will be there also like this. Card status. So this is the condenser actually equipment, process equipment here, and this is in the graphics. Mm. So closed loop I have already explained, but you can see again. Hello, hello. Mm. Mm. So this is the what I can say takeaway for you. This slide, always remember when you are talking about the Honeywell Experion DCS. Anyone can have a field area, you know it from JB. Then you know, must understand the FTA, AI card, AO card, C300 controller, role of FT, control firewall, server functions, DIDO card, series CIO cards. So it is a generalized way. Uh, if this is the Honeywell system, the nomenclature slightly different. FTA, series C, IO link, C300, name, control firewall, FTE. If you are talking about the same slide, general slide, but you are taking comparing with the Yokogawa DCS, then card name will be different. Here Elco board, IO link name will be node IOs, node bus like that, and controller name as I told FCU. There is no control firewall in their system. Server they say something different name HIS like human interface. These are the standard. Field is standard. Then when you are talking about immersion, same thing will happen, and that will compare you. You can compare also. This is what systems. This is a general picture. Only name will be changed here, or maybe some manufacturers, some components are not there. They say it is a part of our controller or part of our server protection. Like this, reasons are there, or functions are incorporated. We can say. Mm. So I think this is what Honeywell system so far. Now we have seen various cards, but when we are implementing particular loop, when we are talking about a medium pressure steam flow, medium pressure steam flow control loop, which is a FIC 1301 I have shown you. But then this particular loop, FIC 1301, how it is implemented, uh, configured in the system. So that is where, as I told, uh, that you have to learn in the Honeywell when we are programs. Uh, so this is what it is there. So you can see any PID loop implementation. For example, uh, uh, this loop, how it is implemented software wise in the server, that we have to learn now. So you see here, just minute. So you can see here the software features. Now we are talking uh, how the loops are configured. You can see this loop, or how this graphic has developed, how to develop this graphic. Then you can see status screens, loops. So how it created on the server side. So that we will see now. There are few 2 3 slides only, but there are some software is required, and there normally your system has to be on the standby or a separate system for training, and there you can try these modules, control modules. And normally in the Honeywell training they teach you, then later on you can practice on your save standby server which is we call as a engineering mode server. There you can try. So configuration of control module, this is a very important. And the software required is a configuration studio. This is the tool, and the name of the tool is a configuration studio in Honeywell Experion um, system. So you can see the configuration studio screenshot. So this is the, when you are in the system, you can see the multiple windows here. These are the tools, toolbars. This is one window where we have normal explorer. This is another window. This is third window. So multiple windows, and you can see here uh, root directory AI FIC 101. Under that, this is your controller, CE environment, this digital input, digital, like this it is there. And these are the soft wired. See, these blocks you have to select: AI block, AO block. This is the AO block. A input is coming from here. So it is going to this controller loop, and like this you can design your strategies here in the configuration studio. And that is called engineering drag and drop. Only just select and drag and drop the tools and connect it. So how to configure? So configuring the C300 controller, first of all, you have to configure the controller. Configuring the IO link means these are the hardware components you are going to use. First, there are, suppose you have 4 5 controllers. So which controller you are going to assign your loop? Then which IO link? Configuring input output modules, which analog input card, which analog output card, or digital input or digital output, that you are configuring. So these are the when you are configuring, so you have to first configure controller, then configure IO link, configure the input output module, configure. Then fourth step is loading the controller. Means once you are configured all required parameters enter, then loading the C300 controller. Means loading or downloading, I like this IO links and IOM. So once you have configured and then loading means downloading the controllers and whatever accessories or cards used, and then activating the controller. C300 is the name of the controller there. So these are the steps. So first configuring the controller, configuring the IO link. IO link is linking with the input output card, then actual input output card, and then these three devices are linked together: input output and controller linking through this network. IO link is a communication protocol for input output linking, and the name of the communication protocol is IO link in the Honeywell system. Normally it is a standard bus. So this is what the steps involved in the configuration of the loop in the C300 controller. So configuring the controller, configuring the IO link, configuring the input output module, loading these devices and the activating. So how to first configure the control module. Now actual control module is a PIC 103 or LIC 10 like this. So first what you have to do, open control builder through configuration studio. So when we open the software configuration studio, then in the configuration studio there is control builder is the software tool. Select file, that will be new, and then control module. Double click the blank chart background. Fourth step is on the main properties tab. Enter the data of a name, item name, parent asset description. Click. Once you enter this information, click the button and save and close. So this is your 11 underscore FC10 control module, which you have named it. This you have done through step 4, main properties. You have entered this because this was a new, and with in this what is a new? So 11 underscore epsilon. Then step 6 is configure the parameters. Now you have created, like we have creating a folder in the Explorer normal PC similar. So configure the parameter for 11 underscore FCO control module. If the main property page is not open, right click on this 11 underscore FC01 and select the module properties. That's all. Normally you right click and just we check the properties are in the files or folders, same thing. So you'll get a main property page here. And step 7 is enter the following parameter details in the main tab. Enter engineering unit for the tag. So the pressure is there, then pressure units there. There is a drop down and all. So that units like a meter cube per hour, maximum 16 characters are allowed. Then accept the, because this is a flow loop, so flow in terms of meter cube per hour, pressure hoga to pressure kg per centimeter square, like this. Accept the defaults. If the values are already taken, then accept the defaults for any remaining parameters on the main tab. So once you have entered it, default values are already coming, you need not to bother and just accept it in the main tab. So when you are creating particular module, these are the steps. And as I told, to configuration studio software, even here it is also mentioned. uh, Earlier I have shown one screen here, configuration studio. This, under this configuration studio, you have to open control builder, and through this you can see here like these drop downs and drag and drop like this. Mm. So step 8 will be click the server display tab, enter the following display details: point detail display, system data point, click the OK button, assign the control module to the controller. So this is what the name of the controller, and you assign this control module F- 11 underscore FC01 to this controller. Step 8 is a configured display, means automatically you will get what displays you require, like a point display, detail display. So these faceplates are already prepared at the backend software, and that only you have to assign, because your control module require detail display and point display. So once you are in the step 8, link to that, assign to that, and assign the control mode to the controller. Then add function blocks to the control module. So once you have done this, now function box like AIO blocks that you have to add. So add function block to the control module, drag AI channel, a- analog input channel into the 11 underscore FCO project chart view. Means you selected a card, AI card, and which channel for this because you require a single input. So channel one channel. So that channel you have to drag to this project chart view and configure AI channel parameter. Then AI channel parameter. Suppose this is the flow coming from transmitter, flow transmitter. So the range, alarms, units, everything, these parameters will be there. So you have to configure and assign this AI channel to AI module. So that module you assign. So this way you are assigning your AI channel or AI card, one of the channel to this control module, that is 11 underscore FCO. The once you have assigned, then connect the function blocks. Connect means soft wiring. After adding the function block, wire them together to form a control strategy. Means this I'm talking. Once you have done this exercise, assign and channel, so the detail will be coming here. This detail, as you can see here, this detail comes here, and this channel you are soft wiring to the PID block input, or we can say PV, process value, right? And this is the output of the control, like this. So you have done this, and then click file, save, download, and click OK. So this is the last stage. You click the file, save, download, and OK. So these are the steps in configuring the control module, but it requires hands-on training. So I think, as I told, either at companies where you are there they show you actually on the simulation mode, or you can join the programs. So this is what we have discussed. Now these are very simple, whatever I have told, it's a very simple way I have just broadly written, and it's a very easy, user friendly. You can, within one day you can learn it. That's all. I think that much easy it is there, though the program is 3 days or for 1 week. But first day you will understand how to create, then later on other features you can learn it. Now I will explain you how to create a display, and the name of that they call it the HMI web display builder, like control builder for engineering creation of the module, display builder. So this is the name, HMI web display builder. So then again, software tool is HMI web display builder. From the start menu, click start. You are on the server, under the server programs. Then under the program you can have Honeywell, Experion, PKS, then the server, and in the server, one, two, three, whatever names are there, one of the server, and then you can have HMI web display builder there on the server. So on the HMI web display builder, application will launch with a blank display. Once you click on this, it will be showing a blank display. Then create a new display. So you have to create a new display. Click on the new display icon to create the standard displays. So you'll get a standard display icons or pictures. So configure HMI web display builder options. Under this, click on tools in the menu bar and select the option from the drop down menu. Select the option as per required. So everything is there, only you have to do the hands on this. Go back to the, like our we do in the normal paint and all, we do how create a picture, or drop down it, or archive it, or crop it, like this. So go back to the blank window of the display and add objects, shapes, text required. So then if you have, there is a library of the picture, take that library, add that object, different shapes, and there are text boxes, you can text it as per your requirement. Save the display, select the file on the menu bar, select save as. Browse the path you need to save, click save. So to preview the display, select the file, click preview, click close when finished. So you can recheck your graphics also. So these are the steps as involved in creating a display, which you have seen in the server station condenser stripper displays or other displays you have seen. So these displays are created like this, and they these once you are created, then it is a link to your control module. Hello. So I think this is the what briefly about the
Yes, sir.
Honeywell system. So I think we are now at the last slide. So thank you very much. If you have any
Okay, sir.
question,
Okay.
uh,
Thank you very much for sharing.
thank you.
I will share tomorrow's schedule with you.
Okay, thank
Okay.
you.
Okay,
Thank you,
sir.
madam. Thank you. Sorry.